In this video, we are going to learn how to graph logarithmic functions. So the first thing I'm going to do, remember function notation, h of x, that represents your y variable. So the first thing I'm going to do is I am going to rewrite that equation so that I can see the y value, and then I'm going to put it in what we call exponential form. So when we go to exponential form, this is always your base, and then the term by itself is always your power. So what we're saying is that is equal to x minus 2. Now, it's easier if you'll go ahead and get that x by itself, because then we're just going to build a table so that we can plot points. So we have 1/2 to the power of y, and then plus 2 is equal to x. So what we will do is we will build a table, but notice that in this case, let me actually move my table over. In this case, it's going to be easier to figure out what y values we want to plug in and then plug them in to find the x. And just like with exponential functions, I would suggest you do things like -2, -1, 0, 1, and 2. So let's start with that and see what we've got. Okay, so when I plug a y value of -2, I have 1/2 to the power of -2, and then I have to add 2. So remember, a negative power is going to flip a base over. So if I have 1/2 to the -2, that's the same as having a positive 2 once I flip it over to the power of positive 2, and then plus a 2. So 2 squared is 4, and 4 plus 2 would give me 6. So on my graph, I would have a point at 6, -2. Okay. Next y value I'm plugging in is -1. So I'll have 1/2 to the power of -1, and then add 2. Again, that negative power flips the base over. Once it's flipped, the power is positive. So 2 to the first is just 2, and when I add 2 more, I get 4. So that point would be at 4, -1. When my y is 0, 1/2 to the power of 0 is just going to give me a 1, and 1 plus 2 would give me 3. So that point's at 3, 0. When y is 1, I have 1/2 to the first plus 2, and so 1/2 to the first is just half. When I'm adding 2 and I get a common denominator, that's like saying plus 4 over 2. So you get 5 over 2, which is like 2.5. So that would be my next point there. And then finally, when y is 2, I'm going to have 1/2 squared and then plus 2. 1/2 squared is a fourth. When you're adding 2, but you think of a common denominator, that would be like 8 over 4. So you're left with 9 over 4. And that's like the decimal 2.25. And so that would be my next point on the graph. Okay, so as we can see, we get a curve here, and it appears to be following there's a vertical asymptote there at 2, so we're getting closer and closer to that 2 without actually crossing over. Okay, so again, we will look at the next one with the table as well. I will point out on the last one, you can look at some graph shifting with these. So if we just had the log base 1/2 of x, you would have a graph that got closer and closer to the vertical line of x equals 0. So what the plus 2 did is it shifted it over. So you could also think of the graph shifting. But I'll approach this one with the table as well. So again, I'm going to first write it in terms of y equal the log base 8 of x plus 3. And then I'm going to go ahead and, so that I can put it in exponential form, I'm going to have to first subtract the 3 from both sides. So y minus 3 is the log base 8 of x. And now when I go to exponential form, so 8 is my base, it is raised to the power of y minus 3, and then I would say that's equal to x. So once again, it's going to be easier in this case if you choose your values of y to plug in so that you can figure out the x's that go with it. And again, I'm going to use -2, -1, 0, 1, and 2. So when y is -2, that means I have an 8 to the power of -2 minus 3. And so that would give me an 8 to the power of -5, which is the same as 1 over 8 to the 5th, which is going to be a very, very small number. So just as close to 0 as you can get when you're graphing it. So that point, and then the y value is -2. So just as close there as you can get. When my y value is -1, I have 8 to the -1 minus 3. So that would be 8 to the -4, which again would be the same as 1 over 8 to the 4th, which you can multiply that out as well. But again, it's just a small, small number. So it's a little bigger than the previous ones, but we're still very close to that particular y-axis. When y is 0, I get 8 to the 0 minus 3, so that would be the same as 8 to the -3rd, which is 1 over 8 to the 3rd. It's a little bit bigger, not much, so it's kind of hard to show that difference on the graph. When y is 1, I get 8 to the 1 minus 3, so 8 to the -2, which is the same as 1 over 64, or 1 over 8 squared. So again, we are still talking, we're not even anywhere close to 1 in this case. So like I'd have 1 way spread out because we're nowhere near close to that. These are so squunched together. And then finally, when my y is 2, I get 8 to the 2 minus 3, which would be 8 to the -1st, which is 1/8. So when x is 1/8, my y is at 2. So you're getting a graph that looks more like that.